I started my PhD on an area where we do reuse and recycling, more on waste minimization. In the past 15 years or so, we started some sort of branching out as a hobby to do a research on climate change. And to begin with, let me just show you something that I experienced some years ago. We heard about climate change about, say, 2 decades ago, but actually when I really feel it, it was in the event when I went to Europe. That time they told me that this is going to be the coldest winter in Europe. And you look at the picture, it looks like Christmas. Actually, it's not Christmas, it's not December. You look at the title, it says March 2013. This is March 2013. And they claim that that was the coldest winter in Europe. But later on, then they realized that there's no coldest, it's always colder, okay? And this March 2013, one night snow effect is about up to your knees, okay? This is, you talk about 1.5 feet of snow coming out, just one night, snow falls that fill up to the knee. Can you imagine that? This is not December, this is in March. And we are talking about, hey, I thought we are going into spring. They say, yes, but this is, I've told you already, this is the coldest winter in Europe. Okay, well, then a few years later, they said that, oh, sorry, Dominic, that was not the coldest, it's always colder, okay? Now, when we talk about extreme weathers, you may feel that, oh, this is something still very far away. Well, probably many of us still remember this very serious flood in the east coast of Peninsular Malaysia. I took a picture from the internet. This is showing Kelantan back in 2014. This is not too far away. This was just 5 years ago. And many of us were actually there to help those flood victims. Okay, you see how this flood has been affected our daily life. Okay, of course, for those who stay in KL, you always have some sort of sudden flood as well. Okay, that's how we say climate change has changed our life in a way. When we talk about the culprit, what caused climate change? Of course, some people say, nah, no, climate change is none of my business. Okay, you talk to the US president, you say, no, this is not my business. Right. But it's affecting every one of us here, okay? This is one of those main important culprits where you can see this, the molecules are basically affecting each other. The two red one and the one in the middle is the black one. This is CO2, carbon dioxide. Every one of us somehow breathe in and out with CO2, okay? Am I polluting the environment? Well, yes and no. You can't hold your breath anyway. You still have to breathe out CO2 in every moment, all right? And this is coming out in our daily life. The more important thing is this. It is not your breath that pollutes the environment. It is these activities that now make all this climate change problem in our world, okay? We're cutting down trees, and we are getting more and more plants out there, the power plants, our transports, and all this actually emits CO2, whether you like it or not. The moment you drive on a car, you burn the petrol will release CO2, and that pollutes the environment. Of course, the more you drive on the road, the more you're polluting the environment, all right? So this is CO2. So you talk about, well, everyone is driving, so what a big deal, okay? And can I don't drive? Well, yes, you have a choice, but how much choice is there? It's up to you. Now, we talk about the 2014 being the hottest world, the hottest in the world, recorded in history. But as I told you, there's no coldest, it's always colder. This is definitely not the hottest, there'll be hotter in the future. But what I want to point out is that if you look at the charts coming out there, the more important thing is this. You'll notice that 2014 was a year in history of mankind where the CO2 concentration actually exceeded 400 ppm by volume in the atmosphere, okay? What we're speaking now, I think we are approaching 410 parts per million volume, okay? This is one of the important messages that you have to bear in mind. Our Mother Earth is really in a fever condition, okay? You can give him some fever cough mixture if you can, a fever mixture, can you cure it? Well, no simple solution for that, okay? All of us have to do something, okay? I showed this in the National Science Week about 6 months ago in Pusat Sains Negara, and the kids were very sort of attracted to the polar bear. You look at the polar bear who is suffering because of the ice is melting, okay? Of course, this is something very natural happening every now and then, but the issue now is we are getting more and more melt ice in the polar. So that is issue. Of course, some of you may have seen this picture, and many of us were shocked for the past few days because one of our agencies says that in 30 years, Malaysia is going, one-third of Malaysia is going to be immersed underwater. Well, I don't know how true is this, okay? But it become a very big havoc, isn't it? If it's 30 years, it's very soon. Well, if it's not happening in 30 years, it will happen in 50 years, okay? Or 100 years. This is a picture they took in Perth, Australia, which is, if you go by flight, this is 6 hours away from here. And you can see that we talk about 2030, that is the sea level. We talk about 2050, it's coming nearer and nearer. Probably we should set something like this in Port Dickson as well, isn't it? At least every one of us go there, will be aware that, oh, the sea level is coming nearer and nearer, and we shouldn't dump rubbish everywhere. Okay? At the moment you go to Port Dickson on Monday, it will be clean because the Majlis Perbandaran clean up all the mess before the people pollute it again on Wednesday and Thursday, okay? Or weekend, Friday, Saturday, and Sunday. All right, we wish that we can still see our nice, beautiful scenery under the sea, okay? And of course, because of climate change, you see all these dying corals and all those things are happening everywhere. So what can we do? If you are thinking that we need to do something for the Mother Earth, which is the place that we have been living so far, obviously we have to plant more trees, okay? This is quite obvious. Planting more trees means that you absorb more CO2, but the problem is we're now cutting more trees, isn't it? Okay? Of course, another thing we need to do is to reduce waste. If you are still using some plastics, every one of us are using plastics anyway, okay? And try to reduce the usage of plastics, okay, if possible. The less plastics that you dump, the less petrol that you're consuming, and that also means that less CO2 is being released to the environment, okay? If you have not been using plastic, replacing your plastic bags with your recycle bags, please start doing it now, okay? 10 years ago when I started with my, what do you call it, food container, okay? Going out to tapao, all these auntie will look at me with a very strange eyesight. Why this uncle is using a mangkok to tapao, okay? Nowadays, everybody is doing it, okay? You are doing your part, I'm doing my part, all of us are doing our parts in order to save the Mother Earth, okay? Now, if you have come to this talk today with public transport, thank you very much. You at least have fulfilled your quota for reduction, CO2 reduction for today, okay? I took an initiative to put my car in the MRT station in Kajang. I took an MRT all the way to Pasar Seni station and then walked here for 10 minutes. Not too bad. This was 8 o'clock in the morning. It was beautiful. But how many of us have been doing this? Okay? 2 weeks ago when I was in Europe, everybody is on bicycle. This is in Amsterdam, in UK. Bicycles, electric buses everywhere. But we are still far behind. But are we saying that we don't have to be worried about it? No. Climate change affects everybody. Okay? If you have not been traveling with public transport, please encourage you to do it. I have not been driving to Kuala Lumpur for the past 1 year. Okay? I've been very, very fortunate that I don't have to drive it. Okay? Of course, because I stay in Kajang, we have the first station. The moment I sit on the train, I can sit all the way to Kuala Lumpur. Okay? Unfortunately, if you are staying in Cheras, you still have to stand. Okay? But if I don't go to the train station before 8 o'clock, there'll be no car park. Okay? Which is a good sign, because everybody's on train nowadays, okay, which is good. Right now, of course, in more long-term basis, we need to look at how can we reverse a lot of practices that we're doing now. We are still building a lot of coal plants in our country to produce electricity, which should sooner or later move into more renewable energy in terms of generating more carbon-neutral fuels, okay? This is a long-term strategy that we need to adopt as a government. Now, what do I do as my research? Let's say if I want to plan for these few cities, Kuala Lumpur, Klang, or PJ, I have an annual, let's say, energy demand of given by the graph, okay? By the graph up there. This horizontal distance tells us how much energy I will need for these 3 cities, okay? KL, Klang, and PJ. The horizontal distance of that tells us how much energy I need to supply to these 3 different regions. And on the other hand, the vertical distance tells us that how much CO2 I can tolerate in these 3 cities. Over there, it says a number of about 100. This is 100 million tons of CO2. If I would set that as my target, how can I achieve this particular target In other words, how do I not exceeding 100 million tons of CO2 when I have to supply this amount of energy to my cities, okay? Given to us here, we have oil and natural gas. Cheapest is always coal, okay? In terms of price, if you still want to pay the same amount of money every month for your power electricity bill, okay, your TNB bill, we want to use the cheapest possible, and that is always coal, okay? And oil is slightly more expensive and slightly polluting, okay? Slightly less polluting. Natural gas is probably the more expensive but the cleanest. So what you see on the animation is that the three red lines, they're joined together to come a composite curve that is moving to the right-hand side. Okay, I shift it to the right-hand side because the moment I have set a target 100 million CO2 per year, I don't want to exceed that. The only way for not exceeding it is to shift the line to the right-hand side so that you can see the red sign now is on the right and below the blue lines, okay? Because the blue line tells us the limit. If you want to keep it below the limit, I have to push the red line to the right-hand side. So what is the big deal? Okay, now the thing is, this graph, the opening on the left, tells us how much renewable energy I need to plan for my country. If I want to build hydropower plants, or in the future, at the moment we are running a lot of, promoting a lot of solar energy. So that solar energy, hydropower, in the future we probably have geothermal, wind energy, and of course we have a lot of biomass generating power. This has to substitute the opening on the left-hand side. That's the numbers we talk about, how to get that in order to keep our targets stay on par, that 100 million CO2 emission per year or per 10 years basis, okay? This is a tool that we can use in order to keep our emission, our limits, all right? Now, if we have done this job and we still find that, oh, well, CO2 coming out from Klang Valley is still very high, so what can we do? All right, well, we have something in the academic world. This is very, very fancy being discussed, especially for those who are doing energy research. People talk about capturing CO2. Okay, we have this term called carbon capture and storage. Nowadays, people talk about carbon capture, utilization, and storage, CCUS. You capture CO2, you either utilize it or you put it underground. If I want to capture the CO2, let me just show you the animation. I can use it in any other industry that CO2 is being utilized. This is carbon utilization. At the same time, I can also capture and store it underground in some saline water and the depleted oil reservoir. All these things are where we can capture and store CO2 permanently. Okay? However, this technology is still developing. Okay? In terms of demonstration plant, if you want to visit, you can go to Finland and some other countries that they are developing this. Okay? Southeast Asia, unfortunately, we are still very far left behind. Okay? If one day later this technology is commercialized, well, the statistics says that in about 5 or 10 years, if it is commercialized, we should be able to capture about 30% of global CO2 emission. Okay? But bear in mind, this is new technology. So just like anything that we're trying to implement, it takes a long while to come. Okay? We have to prove that the CO2 that you store underground will not come out when it's earthquake. Okay? Of course, we say, oh, Malaysia is very stable, okay? But we do have earthquake, okay, once in 60 years, okay? Right, so all these things have to be accessed in technically, okay? This is what people are doing. And part of my research is trying to develop, okay, if I want to capture CO2, what technology I have to use? If you see those in the middle there are many technologies that we can capture, and there are also many technologies that I can store the CO2 once it's being captured. If your storage is not ready, the moment you capture all the CO2, where do I put it? You can't sell it to the soft drink companies, ask them to put it in the soft drink and we drink it. Okay, even though soft drink has CO2, but this is not something that we want to do. Okay, we want to store it elsewhere which is safe. So one of my techniques developed is to address which plant should we capture, where to store it, and store it using what technology. These are something that has to be addressed in the near term, all right? Now, graphically, if you look at these lines, the red color lines, horizontal distance tell us how much energy we are producing, required. The vertical distance tells us how much CO2 we are generating from all these fossil fuels, okay? Natural gas, oil, and coal. The vertical distance of this shows how much is emitting now. The data diagram there says 31.2. If I set a target, I want to reduce it by half. Let's say I want to reduce down to 15, okay? From 31 down to 15, I will have to capture all this end on the right-hand side, okay? This red color segment at the end here need to be captured. That CO2 amount need to be captured. The issue with carbon capture is that the moment you use some solvent to do capturing, you have to regenerate the solvent. And the moment you regenerate the solvent, that means energy. So if you have a power plant, you install it with the carbon capture technology, it will eat up 10% or 20% of your power output. And that power output is supposed to sell to all of us as a consumer. Then we will have to top up, do a makeup for those carbon captured energy losses, and we have to build new renewable power plant, okay? But doing that means more money to be spent to build new plants, and more money we have to pay in our tariff, in our power bill, okay? Our electricity bill. So those are things that we have to handle in the next 10 or 20 years, okay? Right? Anyway, let me conclude. If I want to, the main motivation when we started this work is because of climate change, okay? When we started it about 15 years ago, well, 12 years ago, we didn't notice that climate change effect comes so quickly and so fierce and affecting all of us, okay? I would say the main agenda for us doing all these things is to keep living on Earth rather than moving our children or grandchildren or great-grandchildren to that planet behind our Mother Earth. That is the moon. You can, of course, you can migrate to moon. We can also migrate to Mars in the future. But if you want your generation, your next generation still live on Earth, this is what we need to do, okay? Try to reduce CO2, try to combat climate change. It is a task for you and I, okay? I'm not saying that you need to leave your car in the car park later and go home with the MRT, but in the next trip, if you can consider taking an MRT, you are helping the country, you're helping yourself, you're helping our next generation. At least we are reducing CO2 by 2%, which is not bad. Thank you very much.